Hi everybody, welcome to another video in Pre-Calculus, section 5.4. In this section, we'll define trigonometric function values for any angles. Previously, we only defined trigonometric function based on an acute angle, meaning using the right triangle. Now, to define a trig function to any angle, first we define an angle in the standard position. The positive x-axis is where it starts, and it will rotate counterclockwise, and that gives us the angle theta. With that, we have this is the y values, and this will be the x values, and the distance from that point is going to be r. So what we have is an initial ray, and we rotate that. After that, we will pick any point. So let xy be any point on the terminal ray. So we use any point on the terminal ray, and in that case the relation is given by Pythagorean theorem: x squared plus y squared equal to r squared, and r equal to square root of x squared plus y squared. And also note that because r is the distance, so r should not be negative. If the point is over here, x could be negative, but that's a different story. Now, let's just, in generic, let's just look at this point. Now, everything we look at in this form, even though the point could be here, we have different triangle. But what we see here in this right triangle, y is, with respect to that angle, y is opposite, x is adjacent, and r is hypotenuse. So just like what we have here, what we have earlier for the trig function, we write out sine is opposite over hypotenuse. Opposite over hypotenuse, so y over r. Cosine is adjacent over hypotenuse, and tangent opposite over adjacent. And cosecant, we're just going to do the reciprocal of all of this: r over y, r over x, and x over y. Right. Of course, when we write the definition like this, notice that we choose r to be the point that is not at the origin. So r is not going to be 0. So that's part we know. But x and y potentially be 0. If x equal to 0, these two functions are undefined. If y equal to 0, then those two functions are undefined. Right. So note that I just write in general, make sure the denominator not equal to 0. Yeah. So that y is not equal to 0, x not equal to 0, and so on. So just write in general. Now, for exact 6 trigonometric function values for the point corresponding to 12 and negative 5. So pretty straightforward. We have x is equal to 12, y equal to negative 5, so r equal to square root of x squared plus y squared, so square root of 12 squared plus negative 5 squared, and that will give us square root of 169, which is 13. Right. So we have x, we have y, we have r. Now we just write the ratio. Sine is y over r negative 5 over r 13. Right. Cosine is x over r. I'll just base on the definition here. X over r 12 over 13, and tangent y over x, y over x. And we just write the reciprocal function, cosecant r over y, so 13 over negative 5. And just put the negative on the top. And then secant is reciprocal of cosine. And then cotangent, reciprocal of this. Right, so just based on the definition. So even though the point x and y, the point here has a y coordinate negative, but we don't need to draw the triangle just like that. Like, because negative 12, x equal to 12, y equal to negative 5. The point is in the fourth quadrant, but just in terms of easy to visualize, we just draw a triangle like this and use the opposite adjacent and hypotenuse to write in terms of x, y, and r. Yeah, right. So as long as we have x, y, and r, we have only 6 trigonometric function values based on these definitions. Right, now let's find special values for 0, pi over 2, pi, and 3 pi over 2. Right, so once again, if we have the x, y, and r, that should be easy. First, 0. If it is 0 degrees or 0 radian, the point will be right here. It does not rotate anywhere. So here, let's choose, we can choose any x values, but the y values is equal to 0. So for simplicity, choose x values to be 1 and y values to be 0. So x equal to 1, y equal to 0, and r, the distance from 0 to that point, from the origin to that point, is 1. Now, based on definition, sine is y over r y over r. Cosine is x over r. Tangent is y over x. Cosecant is r over y. This just flip 1 over 0. Of course, if we divide by 0, it is undefined. And then tangent, secant is 1 over 1. Secant is r over x, r over x. And then cotangent is reciprocal of tangent, 1 over 0 is undefined. Right, so that's what we have. The first case of 0 degrees. Now, for pi over 2 or 90 degrees. So the point will be here. And we can say the x values is equal, whatever it is, but the y values has to be equal to, the y values can be anything, but x values have to be 0. So x is equal to 0, y equal to 1. So x equal to 0, y equal to 1, and r distance from that point to 0 to the origin, so it's 0. It's 1, sorry. Right. Then just the definition. Sine, I should write it here. I think that would be a good idea. Sine is y over r, cosine is x over r, tangent is y over x, cosecant reciprocal of sine r over y, secant is reciprocal of cosine r over x, and tangent is x over y. Right, now that should be easy, right? Sine y over r, y over r, x over r, y over x, r over y, r over x, and x over y. Right. So don't have to memorize anything, just based on definition and whatever the point at, whatever the quadrant it is, just draw it out and then find x, y, and r. Once we have all of those, that should be easy. Next, pi is corresponding to 180 degrees. So 180 degrees, so we will rotate half a revolution, so the point will be here. We can choose x to be anything, but it should be negative. The y value should be 0, so I choose negative 1 and 0. So x equal to negative 1, y is 0, and r is equal to 1. Right, y over r x over r, y over x, r over y, r over x, and r over and x over y. And finally, 3 pi over 2 corresponding to 270 degrees. So it will be here. Y should be negative. X is equal to 0. Let's choose y to be negative 1. So x is 0, y is negative 1, and r, the distance from that point to the origin, is 1. Are always positive. Right, and then the definition, y over r, y over r, x over r, y over x, r over y, r over x, and x over y. Right. So, like I said, you should not memorize any of this. If we answer for the question, just go back to definition using x, y, and r, and then draw where the points are, so we can determine x, y, and r. Now, so in this section we did study that we did try to define the trig function for all angles, any angles. So to reduce a problem, we have coterminal angles, and then later on the reference angle. So coterminal angles, two angles in a standard position are said to be coterminal if they have the same terminal side, meaning that we may have the point for this direction or that direction, as long as the terminal ray will be the same. Of course, the initial ray must be the same. We start from the positive x-axis and we rotate. Could be clockwise, be positive. Counterclockwise is positive. Clockwise is negative. And then we can go on extra revolution. So here we can go from here to get the angle A, or we can go like this. To get to the angle B, as long as they stop at the same terminal ray, we call those angles coterminal angles. They're not the same measure, obviously, but they have the same x, y, and r. Therefore, all of the 6 trigonometric functions will be the same because they stop at the same terminal ray. The point on that ray will give us the same 6 trigonometric function because x, y, r does not change. X, y, and r do not change. So the trig values will be the same. All right. The key here is coterminal angles will be theta and theta plus 2n pi. Well, n could be negative, but it have to be in integers. So we're talking about, by the way, integers, meaning that we have 0 all the natural numbers and negative natural numbers. So that's what we have. So n could be negative as well. Bottom line is, if we're gonna add to n pi, or if we write in terms of degrees, we should have 0 and 360 degrees times n. So 2 pi turn into 360. So either we write 2n pi in radian or 360 degrees times n in degrees. Right. Now, using coterminal angles to find the exact values of trigonometric function cosine 390. By the way, one revolution only go from 0 to 360, so we can use the coterminal angles. And the properties precisely is this: trigonometric function values of coterminal angles are equal. The angles are not equal, but the trig function values will be equal. Right. So here we have 390 degrees. By the way, if we go one revolution, that 360, and then go a little more, so that 390 degrees. We talk about this one. If we talk about the terminal rate, we only need this much. So in terms of calculation, if it is 390, we can add or subtract 360 from it to bring the angle to between 0 and 360. So if we subtract 360, which gives us a coterminal angle, that gives us 30 degrees. So yeah, so 30 degrees is the coterminal angles of 390 degrees. And so we can say just cosine of 30 degrees. Right? Remember the hand trick for 30 degrees. Just go over that finger. And cosine is a number of fingers on the left, so we have square root of 3 divided by 2. Next, tangent of 420. We don't even need to draw it. If it is a number that is too big, we're trying to bring that to between 0 and 360 degrees. Also have 420 degrees. We could minus 360 degrees, so that angle is within 0 and 360, so that gives us 60 degrees. And so 420 and 60 degrees are coterminal, therefore the trig function values will be the same. Right, 60 degrees. Right. For tangent, we have the number of fingers on the right. Take the square root, divide by the square root of the fingers on the left. So that will be square root of 3 over square root of 1, or just square root of 3. Now sine of 9 pi over 4. Now if we have the angle measured in radians, instead of minus 360 degrees, we can minus 2 pi. Or we can add 2 pi. If we have a negative, just add 2 pi to it. Now let's subtract 2 pi. 9 over 4 minus 2. That is a quarter, which is 1/4. So we have 1/4 a pi, or pi over 4. Yeah, when we have 1/4, stick a pi to it, so pi over 4. Now pi over 4 and 9 pi over 4 are coterminal angles. So the trig function values will be the same, and sine pi over 4, and sine will be numbers finger on the right hand side. Take the square root of that, so square root of 2 over 2. Right, so that's simple enough. So if the angle is too much, by too much I mean more than 360, we always can subtract 360 to bring the angle back to between 0 and 360. If it is negative, we can add 360 to it. So we could add a multiple of 360 to it. In that case, we have coterminal angles, where they do have the same trigonometric function values. Right. Next, determine the size of trigonometric function on each quadrant. Right. Now, so if we look at the point here in quadrant 1, we see that in quadrant 1, x is positive, y is positive, and of course r is always positive. If that is the case, in quadrant 1, all ratio, because all of them are x, y, and r are positive, so all trig functions are positive. Next, in quadrant 2. In quadrant 2, let's see a point here. In quadrant 2, x is negative, right? On this side, x will be negative. Y will be positive, and r always positive. Now, if we take two of those x, y, and r divided by each other, unless we have positive divided by positive, will be positive. If there's an x and either y or r, so x over y, y over x, r over x, or x over r, those will be negative. So in the second quadrant, only the ratio that have y and r in it will be positive. So what ratio that have y and r? Sine and cosecant. Right? So like I said, very simple, just based on the definition. So here we have sine and cosecant. Are positive. Everything else is negative. Now, quadrant 3. in quadrant 3, point here, x is negative, y is negative, but r is always positive. Now, just pick any two of this x, y, and r. What ratio will guarantee to be positive? Now, if we use x and r, negative, positive, that will be negative. If we use y and r, negative and positive, so still negative. The only thing that makes it positive is where both of them negative. Negative divided by negative is positive. So whatever ratio that have both x and y in it, we guarantee to be positive. So what ratio is that? So tangent is y over x, and cotangent is x over y. So in this case, tangent and reciprocal of that cotangent are positive. And in quadrant 4, x is positive, y is negative, and r is always positive. So whatever ratio guarantee to be positive. Alright, so we have to choose both of them positive. So we have to choose x and r. So whatever ratio that have x and r in it, which means cosine and secant are positive. Right. And if we put all together, there is an acronym. I say OnStar Text Cache. So in first quadrant, all of them are positive. On the second quadrant, sine is positive. Third quadrant, tangent is positive. Fourth quadrant, cosine is positive. Of course, we talk about the reciprocal as well. Right. Now, I said I don't memorize any of this when we have to do the problem. Just go back to definition using x, y, and r. That should be simple. Right. Now, let's look at this. Determine what quadrant it is, so that sine is positive, cosine is negative. Right. So what is sine? Sine is x. Sorry, sine is y over r. It is positive. By the way, r is always positive, right? Now, we know the ratio will have to be positive because it's greater than 0. So what divided by positive is positive. From that reason, y have to be positive. Because in that case, that ratio is positive. Right? So that is that. Now cosine is negative. Cosine is x over r. We know r is always positive. But the ratio altogether is negative. So because of that, x must be negative to guarantee that this ratio is negative. Now, we just look for the quadrant where y is positive and x is negative. So we're talking about this quadrant, right? So the answer is, this is in quadrant 2. Yeah, look like there's a problem with the calculator. We haven't used that, but it's be fine. So x is negative, y is positive. So this is in quadrant 2. Right. Try to do the same thing. Tangent is negative. Well, this is different. Tangent is y over x. We don't know what it is, but have to be negative. Well, yeah, that could be either both positive or both negative. We don't know. So let's go to the second one. Cosecant. Cosecant is 1 over sine. Sine is y over r. So cosecant is reciprocal of sine will be r over y. Yeah. So we know for sure r is positive. When they divide together, the cosecant is negative. So what do you think this has to be? What y has to be? Y has to be negative, right? To guarantee the ratio is negative. Now if y is negative, what do you think x has to be to guarantee that the ratio is positive? So because of that, x must be positive, right? So that guarantee to be negative when y divided by x. So y is negative. And x is negative. Sorry. Y is negative and x is positive. So what quadrant is that? Y is negative, so it's below here, but x is positive. So we're talking about this one, which is quadrant 4. Right, I said, just based on the definition, x, y, and r. Right, next we have the reference angle. Reference angle. Let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal sine of theta and the x-axis called the reference angle. So this did not say with the positive x-axis, so it could be either positive or negative. And let's just denote that the reference angle use the hat. Right. So if we have this angle, then the terminal ray is this, and we will form with the x-axis whatever give us an acute angle. Acute meaning between 0 and 90 degrees. So in this case, this is the reference angle. If we have an angle that goes this much, the reference angle is the terminal ray, and with the x-axis either positive or negative. In this case, that is the reference angle. So if we have that angle, the reference angle would be this much. Because we just form the terminal ray with the x-axis. Doesn't matter if it is positive x-axis or negative x-axis. Because if we go this way, it's positive or negative, doesn't matter. As long as the terminal ray and either positive or negative give us the reference angle. Right. Next, find the reference angle for each of the following angles. So 150 degrees. Right. So before we do that, let's write something more general. This is in quadrant 2, right? So in quadrant 2, in this particular case, reference angle is equal to 180 degrees, which is the whole half angle. I mean the whole straight angle minus theta give us the reference angle. Now in quadrant 3, the reference angle is equal to 360 degrees minus theta. By the way, this of course we only talk about the reference angle where the angle is between 0 and 360. if we talk about the angle that go a lot of revolution around it, then that might not be this case. If we go a bunch of revolution around it, we should subtract 360 until we have the angle that is between 0 and 360. Then from there we determine the reference angle. Right. Then quadrant 4. So in this case, we can just say theta reference angle equal to 360 degree. Sorry, this is completely off. So theta equal to theta minus 180 degree. Alright, so the whole big angle take away a straight angle, so it should be that. Now this is 360 degree, the whole thing take away the angle itself. Right, sorry about that. So the big angle subtract 180, and this, if it is in the first quadrant, it will be the same. By coterminal angles, we could add 360 to it. We can do that to all of them, still the same. That's what happened in quadrant 1. But once again, if it is any confusion, the definition, just go back to the trig function using x, y, r, coterminal angles, meaning they have the same terminal ray, and reference angle, meaning the terminal ray with either positive or negative x-axis. Right. Now if we can kind of sketch, we'll be able to find the reference angle. Don't have to memorize any of this, just based on definition. 150 degrees, well, we know that is 0 here, 90, 180, 270, and back to 0 or 360. Now we talk about 150 degrees, so we stop here. And so we have the terminal ray is this. So we take that terminal ray, and we will use this x-axis, the negative x-axis, because in that case this will be negative. I mean, the angle will be between 0 and 90 degrees. So 180 is the whole thing. Subtract 150, give us what's left. So the reference angle of 150 is 30 degrees. Now negative 45 degrees. Of course we still have 0, 90, 180, 270. If we go clockwise, negative 90, negative 180, negative 270, and so on. So negative 45 degrees. Is clockwise, negative 45 degrees. So the reference angle will be whatever it is, formed with the positive or negative x-axis, but the angle must be acute. So in this case, if it is negative 45 counterclockwise, I mean negative 45 clockwise, reference angle, we just take the clockwise. So we just say the reference angle is equal to 45 degrees. If it is clockwise of negative 45 degrees, counterclockwise will be 45 degrees. Right, 9 pi over 4. Well, 9 pi over 4 we did see before. 9 pi over 4. 9 over 4 is more than 2 pi, meaning it is more than a revolution. So in terms of radian, 0, pi over 2, pi, 3 pi over 2. So we go 0, and let's say we go 1 pi, 2 pi, and 1/4 of a pi. So we stop here. So to find reference angle, first, of course, if we want to simplify things, we can always reduce this. subtract 2 pi. To do that we get coterminal angles. So 9 over 4 minus 2. We have 0.25, which is pi over 4. So we can get the coterminal first, and if it is pi over 4, that in first quadrant, so that also, so reference angle is also pi over 4, also because we take that terminal ray with the positive x-axis, and that's what we have. So if it is in first quadrant, that will be the same. So we have coterminal angles have the same terminal ray. Reference angle terminal ray to either positive or negative x-axis. Right. Now we have the reference angle theorem. The theorem says if theta is an angle that lies in a quadrant, and if alpha is the reference angle, then sine or any trig function is equal to plus or minus the same function of the reference angle. So when we go from trig function, just go to the reference angle, it could be positive or negative of the reference angle. So in that case we can find any trig function values based on the reference angle and where it is, in what quadrant it is. So first, 135 will be here, right? 90, 180, so we have 135. Now, the reference angle, we take the terminal rate from with the x-axis, could be positive x-axis, could be negative x-axis. So that gives us whatever that is. So the whole thing, the whole tray angle is 180 minus 135. So first, the reference angle is equal to 180 minus 135 is 45 degrees. So the reference angle is 45 degrees. Next, cosine is in the quadrant 2. In quadrant 2, is cosine positive or negative? Cosine is x over r. X is negative here in quadrant 2, so cosine is negative. So, and that easy. We start with cosine of 135 degree. According to that theorem, it could be plus or it could be minus cosine of the reference angle. Reference angle here is 45 degrees. Right? So we can go from a trig function. Of an angle to a trig function of a reference angle. Could be plus, could be minus. But we just show that it is negative, right? So it's going to be negative. And then we have an angle between 0 and 90 degrees. We can use this. 45 degrees. Cosine is number of fingers on the left. That's 2. Take square root of that. Divide by 2. So square root of the number of fingers on the left. Divide by 2. So that's what we have. Next, tangent of 600 degrees. So first, 600 degrees is a little bit much. So let's subtract 360 to bring this down into an angle between 0 and 360 degrees, so it's easy to manage. So 600 degrees minus 360 is 240 degrees. So instead of do 600, 240 will be easier to handle, right? So where is 240? 0, 90, 180, and 240, so somewhere in here. So to get to a reference angle, we will take the terminal rate formed with the x-axis. Could be positive, could be negative. So we're going to choose that. And so the whole thing is 240. Take away a half a revolution. So reference angle is 60 degrees. Now is that positive or negative? So in quadrant 3, tangent is positive. Remember, own store takes cash. In quadrant 3, tangent is positive. After all of that, we say tangent of 600 degrees will be the same as plus or minus tangent of the reference angle. And we know it's going to be positive. Because in quadrant 3, and tangent of 60 degrees. So tangent will be square root of the number of fingers on the right over square root of fingers on the left, or sine over cosine. So we have square root of 3 fingers on the right, 1 on the left. Just square root of 3. Right. Of course, if we use the calculator, it will not give us the answer directly. But most important, make sure that it has to be in the right mode. So this is in degree mode. So tangent of 600 degrees is positive. And it did not give us square root of 3, but we can type square root of 3 and those values are exactly the same. So we're good. Right, more example. 17 over 6. Well, that's more than a revolution. What is 17 over 6? So it's more than 2 pi. If it's more than 2 pi, meaning that it is more than a revolution. So we take that minus 2 pi and convert to fraction, 5 or 6. Yeah, minus 2 pi to bring it to within 1 revolution. If it's not enough, keep subtracting 2 pi. If it is too small, if it is too negative, add 360 to it. So the point here is we can add 360 or multiple of 360. In this case, multiple of 2 pi. And we have 5 pi over 6. So we have here 0 pi, 5 pi over 6, so a little bit less than that. So if we take the terminal ray formed with the negative x-axis, we have this is the reference angle. So reference angle, the whole thing is 180 or a pi. Subtract 5 pi over 6. Give us a pi over 6. And then this is in quadrant 2, right? So in quadrant 2 is sine positive or negative. So own store, take cash, second quadrant sine is positive. So it is positive, so we can say sine of 17 pi over 6 is plus or minus sine of 5 pi over 6, pi over 6. And we show that it is positive. So pi over 6. Sine is the number of finger on the right. There's one finger on the right. Take square root of that. Divide by 2. So that's 1/2. Simple enough. Now cosine of negative pi over 3. Now this should be simple. And negative pi over 3. So the reference angle is easy, pi over 3, right? Just go backward and that terminal ray with the positive x-axis. And then this is in quadrant 4. Cosine is positive or negative. So open store, take cash. So in last quadrant, cosine is positive. So we say cosine of negative pi over 3 equal to cosine pi over 3 plus or minus. But of course we're going to choose positive. So cosine pi over 3, cosine is the number of fingers on the left. Square root of that divided by 2, so it's also 1/2. Right, we can confirm this. Did not give us the answer directly, but this is in radian mode. So keep the calculator in radian mode. Cosine of negative pi over 3. We have that 0.5. Well, 0.5 is 1/2, so at least we have the answer directly. So that's good there. Right, so yeah. So to find a trigonometric function of any angle, first we find with what quadrant it is in. With that, we can determine if it is positive or negative. First, determine the quadrant. Second, determine the reference angle. The reference angle will give us the values. So we have the sine from the quadrant and the values based on the reference angle. Of course, if we can go back to reference angle of anything between 0 and 90 degrees, that will be easy. Right, and this one, quickly, I just want to show you this little trick that I use. So let's say I ask you in general, what is the reference angle of 1/13 pi over 6? Right, now if it is in radian mode, if this fraction is irreducible and it ends up with 6, then the reference angle is pi over 6. If we have, let's say, 7 pi over 3, reference angle would be pi over 3. But that fraction has to be reduced. If you have like 10 pi over 4, well, that's not it, right? We have to reduce. In that case, that is not reference angle will be pi over 2. Because the way we define that, yeah, it is like in a quadrant, meaning that it is not in quadrantal angle. So in that case, that is kind of like 90 degrees. Right. So make sure that fraction is reduced. I mean in radian, reduced. If we divide by 6, quadrant reference angle is pi over 6. Right? Divide by 6. If divide by 3 at the bottom, then reference angle is pi over 3. If it is divisible by 4, I mean, if we have 4 at the bottom, then the reference angle is pi over 4. So once again, if it is in terms of radian with the pi like this, if we have 6 at the bottom, pi over 6 as the reference angle, 3 at the bottom, pi over 3. 4 at the bottom, pi over 4. But that fraction has to be reduced. Right, so that. Now, you say, what happens if we have degrees? Well, degrees is a little more complicated. So for degrees, we're going to have to try this. First, divide by 90 degrees. If it is even, if it is the whole number, then yes, reference angle is 90. If 90 doesn't work, go to 60 degrees. If 60 degrees doesn't work, go to 45. If 45 doesn't work, go to 30. What is the first number that it is divisible by will give us the reference angle. Now let's go back to the previous example and see. 600 degrees. Well, try to divide by 90. No, it's not a whole number. 600. How about 60? Yes, that is the whole number. So the first thing that happened, that will give us the reference angle of 60 degrees. Right. Now, how about 135? 135. Divide by 90, obviously not. 60, nope. How about 45? Yes, so reference angle is 45 degrees. Now this work only for multiple of 60, 30, and 45. So where we have the nice values for this. If it is like 27 degrees, then I don't have the values for it. But in big scheme of things, how about 750 degrees? Let's divide by 90. No. How about divide by 60? No. How about 45? Still no. How about 30? Yes. So, yeah, yes, because it come up with the whole number. So when we divide the first whole number, we have the 30 degrees. That is the reference angle. So, by the way, it only works for 30, 45, 60, and 90, as it is in case of pi over 6, pi over 4, pi over 3. Right, that's the reference angle. Now just based to the definition. Suppose cosine is equal to this. Find the exact values of the remaining trigonometric function. Right. So first, cosine is equal to negative 2 over square root of 5. The ratio for cosine, what do we know about that? X over R, right? And the ratio is set to be negative 2 over square root of 5. So with this, R is always positive, so we can choose R to be square root of 5 and X being negative 2. So we have X, we have R. If we have Y, we have all the 6 trigonometric functions, right? So X squared plus Y squared equal to R squared. Pythagorean theorem. X squared is negative 2 squared plus Y squared equal to R square root of 5 squared. So I have 4 plus Y squared equal to 5. So Y squared is 1. So Y equal 2. Don't forget, when we take square root on both sides, it have to be plus or minus. Plus minus square root of 1, which is plus or minus 1. So is this plus 1 or minus 1? Well, I have to go back to our problem. The angle is between pi over 2 to pi. So in terms of quadrant, where is that? 0, pi over 2, and pi. So this one between pi over 2 and pi. So this is in quadrant 2. In quadrant 2, y is positive. So in this case, y is equal to 1. So we know x, we know y, we know r, we have everything. So we have cosine. Sine is what? Y over r. Y over r. cosecant will be reciprocal to that. Square 5 over 1 or square root of 5. Cosine is that, so secant reciprocal. Just flip, square 5 over negative 2. Tangent y over x, y 1 over x. Cotangent is reciprocal of that, so flipped, x over y, x over y. So it's simple enough. As long as we have x, y, and r, we have everything. So in this case, x is negative 2, y square root of 5. I mean, x is negative 2, r is always positive, square root of 5. So that's why we can choose r to be square root of 5, x is negative 2. Next problem might be different. And then in this case, y plus or minus 1, we're going to choose 1 because it is in quadrant 2. Right. Once again, using definition, if we have x, y, and r, we have only 6 trigonometric function. Now tangent of theta is equal to negative 3, cotangent, cosine is negative. So what do we know about that? First, we know tangent is y over x. And we know that this is negative 3, could be 3 or 1 over 1. Now the question is x negative or is x positive? Right? Unlike the last problem, we know for sure r is positive, so x must be negative 2 here. So this one we don't know. Should the negative go with y or negative go with x? Right, to determine that, we have cosine is negative. So what is cosine? X over r, right? And r is always positive. And when we divide them, the ratio is negative. The ratio is less than 0. Now, what x has to be so that the ratio will be negative? Well, that's obvious, right? From here, x must be negative. So x is negative. So from here we can choose x to be negative 1 and y to be 3. Now when we have x and y, we can solve for r using Pythagorean theorem. X squared plus y squared equal to r squared. So negative 1 squared plus 3 squared equal to r squared. So r squared equal to 10. And r equal to plus or minus square root of 10. However, r is always positive, so we don't have to do any reasoning. So just square root of 10. We have x, we have y, we have r. We should have everything. So in this section, we've learned a definition of a trigonometric function in terms of x, y, and r. Just stick to that definition if everything. Don't try to memorize anything without understanding it. And like I said, these values can get as soon as we know x, y, and r. We know x, y, and r, we can determine if there is positive or negative in certain quadrant. Right, so let's finish this problem. Sine y over r, y 3 over r. Of course, it mentioned that if we don't want square root at the bottom, multiply that top and bottom. We have 3 square root of 10 over 10. Of course, we don't need to do that. We can just say 3 over square root of 10, which is perfectly fine. Right. Sine is that, cosecant is reciprocal of it. So just flip square root of 10 over 3. Next, cosine is x over r. X is -1 over r square root of 10. Once again, if we don't want square root of 10 at the bottom, multiply that top and bottom, give us negative square root of 10 over 10, and reciprocal of that, which is going to flip square root of 10 over -1 or negative square root of 10. Right? And finally, we have tangent. So cotangent, just reciprocal of that. Just going to flip this -3, so -3 over 1, or 1 over -3, or -1 over 3. Yeah, just -1/3. Yeah. So as long as we have x, y, and r, we can have all 6 trigonometric functions, and that the emphasis here. Of course, we have also coterminal angles and reference angle. That will help us to simplify any big values like this. We go to coterminal angle first. Yeah, subtract 360 if it is too much, add 360 if it's negative, until we have an angle between 0 and 360. Get an angle in the nice within one revolution between 0 and 360 first. So get to the coterminal angle first, and then go to the reference angle, and then the trig function values will be the same. We only need to determine if it is positive or negative. To determine positive or negative, all we need to do is just find what quadrant it is. Knowing the quadrant, we can determine if the trig function is positive or negative, or just based on definition, right? Like this, where we know if the ratio is negative and r is positive, then x must be negative, right? So, like I said, just a definition. If there's any confusion, just go back to the definition. Right, with that, I stop this section here. As always, thank you for watching, and see you in another video in pre-calculus.